Imagine you're an engineer in the US, responsible for the systems that keep your company alive. One Monday morning, your CIO asks you to add AI agents to the MCP mainframe, but here is the non-negotiable ask. Reliability cannot budge, but you are not worried, because you know this isn't a rewrite, it's a controlled upgrade that adds judgment to a backbone you already trust. Welcome to today's video. We'll be covering why MCP still matters, where it strains, what agents add, the safe bridge patterns and guardrails, the adoption path. If you're still using old FANG prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern FANG interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan. The exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
Hello everyone. I'm really excited to be here with you today and talk about something that I think is going to fundamentally change how we think about enterprise computing. We're going to explore how to take these incredibly reliable mainframe systems that have been running over critical business operations for decades and enhance them with intelligence of modern AI. I'm going to be covering modernizing MCP batch processing with AI agents. So I'm Nahid Farhati Ghalati, and just to give you a brief background about where I'm coming from, I got my PhD from Virginia Tech back in 2016. And since then, I've been deep in the trenches building and leading engineering teams that focus on large language models, evaluating them, fine-tuning them, and getting them to actually work in production environments. I've done this at Microsoft, Google, Capital One, and Accenture, and basically everywhere, wherever there are complex problems that need machine learning solutions. And I'm always learning. Right now, I'm working with folks at UC Berkeley to keep pushing the boundaries of what we can do with AI. So here's the question that's been keeping me up at night. What happens when you take a system like MCP, which has been rock solid reliable for over 60 years, and you give it the ability to think? That's what we are going to be diving in today. So just a brief introduction. Before we get too excited about the AI stuff, we need to understand what we are working with. How many of you have actually worked with MCP systems? So MCP, which is Master Control Program, has been the operating system for Unisys mainframe since 1960s. I want you to think about that for a second. This system has been processing payroll, handling banking transactions, and maybe insurance claims for over 6 decades. That's not just impressive longevity, but that's the proof that when you build something right, it lasts. MCP does basically 3 things: job scheduling, resource allocation, and batch processing. And when I say it does them well, I mean it handles the kind of workloads where if something goes wrong, people can lose their jobs, companies lose millions of dollars, and sometimes even lives are at stake. So what makes MCP really special? Basically, first, sequential job execution with strict dependencies. Every job knows exactly what has to finish before it can start, and what's waiting for it to complete. It's like a perfectly choreographed dance that's been running for decades without missing a step. Second, centralized resource management and security. You know how modern distributed systems can turn into security nightmares with all the different services taking over each other. MCP doesn't have that problem. Everything goes through one central control point, one place to secure, and one place to monitor, and one place to audit. Third, comprehensive logging and auditing trails. And I mean comprehensive. Every single thing that happens gets logged. Every resource allocation, every job execution, every security check. And finally, 99.99% uptime. I'm not talking about some marketing claim here. These systems routinely achieve uptime that makes modern cloud services look unreliable. We are talking about systems where being down for 5 minutes a year is considered a really bad year. So now, let's look at the core functions and architecture of MCP. First, High availability and fault tolerance. This isn't just about having a backup system. MCP is designed so that individual component failures don't bring down the whole system. It's like having a building where if one support beam fails, the others automatically strengthen to compensate. I've seen these systems keep running through power outages, hardware failures, and natural disasters. Second, resource and workload management. The scheduling in MCP is really beautiful. It's doing sophisticated job scheduling, memory management, I/O control, all optimized for both batch and interactive workloads. It's like having a master conductor who can manage hundreds of musicians at once. Third, modular kernel and scalability. Here is something interesting. This modular microprogram kernel design was revolutionary in the 1960s. It allows the system to scale across processes, improve parallel processing efficiency. Some of the architectural decisions are still elegant solutions today. And finally, security and data protection. The security subsystems enforce strict controls and auditing. These systems handle everything from payroll to national security data. The security model is simple and centralized and basically really effective. The workflow is predictable. A job gets submitted, then they are queued based on priority and dependencies, resources get allocated, the job executes, results get logged, resources get freed up for the next job, and then basically it's split. So the role of batch processing in MCP environments is also really important. There are multiple parts to it. First of all, the fundamentals. MCP handles sequential or parallel processing of huge job volumes without any human intervention. For example, imagine you have 50,000 employees who need to get paid on Friday. You don't want someone sitting there clicking process for each paycheck. The system just needs to handle it. Second, critical business applications. We are talking about financial updates, payroll processing, massive data transformation. This is an optional functionality. This is the stuff that keeps business running. Third, resource optimization. MCP's batch scheduler is incredibly good at balancing workload priorities and dependencies to squeeze every ounce of performance out of expensive mainframe hardware. These systems don't want to waste any resources. Finally, operational efficiency. All the heavy lifting happens at 2 a.m. when nobody is trying to use the HR system. It's brilliant from an operational point of view. But, and this is a big but, we are running into some serious limitations in our modern business environments. First one is being static job scheduling. These manual fixed schedules lead to poor resource utilization and delayed job completions. If a job finishes early, the system just sits there waiting for the next scheduled job instead of taking advantage of available resources. It's like having a brilliant chef who can only cook at predetermined times, regardless of when customers are hungry. Lack of real-time monitoring. Often there is no real-time visibility into the job execution. You might not know a critical job failed until hours later when someone notices the report didn't generate. By then, you need to basically fix during business hours. Increased operational costs. These rigid systems need constant human oversight. You need a specialist to understand these systems, and they're getting harder to find and more expensive every year. Plus, every single workflow change requires a programmer. And finally, scalability changes. The monolithic architecture really makes it really hard to integrate with modern applications and cloud platforms. You end up with these data silos that prevent unified analytics and, cross-system workflows. So basically, there's a lot that needs to get fixed here. Other points are data silos and interpretability. MCP processes basically large volumes of data, but it creates silos that obstruct unified analytics, and it provides resource and processing constraints and mitigates those constraints for us. Basically, when we don't have enough hardware or software, it makes sure to optimize the process for performance and scalability. So now let's look at just the problem with batch jobs. There are four main points that I want to point here. One is fixed logic versus dynamic content generation. Traditional jobs are basically sophisticated calculators and they follow predetermined scripts. They execute the same operations regardless of what's actually happening in the world. But imagine a financial report that doesn't just crunch numbers, it provides analytics based on current market conditions, regulatory changes, your business strategy, and that is basically dynamic content generation based on real context. Second, no intelligence versus intelligent decision making. And so if something happens unexpected, the traditional systems either failed or produce garbage results. There is no intelligence. But with AI agents, they can make intelligent decisions during execution. They adapt their approach based on the data that they encounter. Third, manual updates versus self-optimizing workflows. Every change to a traditional system requires a programmer to modify the workflow. But with AI agents, we can create self-optimizing workflows that learn and adapt over time, and they improve their performance based on historical data. Finally, limited output versus rich business value. Traditional batch jobs process data, but they don't generate insights. They might calculate totals, but they don't tell you what those totals mean. AI agents produce rich, human-readable outputs that provide real business value, analytics, recommendation, and actionable insights. Now let's move to actually what is an MCP, the MCP protocol for AI. Now we get to the interesting part. This is where, we bridge traditional enterprise computing with modern AI capabilities. So MCP protocol operates on a client-server architecture with a standardized message passing. Think of it as a sophisticated RPC system, but one that's really specifically designed for AI interactions. So it also has the capability to be integrated with different tools and provides access control over different, application resources and contextual data. So when we think about REST APIs in web development, it connects different web applications to data and services. And when we think about MCP in AI ecosystem, then this connects AI applications to tools and data. So now when we think about the real MCP workflow, as I said previously, we submit a job and a JCL defines job parameters, then the jobs get queued and the scheduler manages the different job priorities, then the resources are checked, do we have enough CPU, do we have enough IO, etc. The job gets executed, the logging and auditing trails are provided as part of this process, and finally we archive the job. So here is an MCP architecture deep dive. As I showed in the previous slide as well, this one is more detailed. For example, the message, there are multiple layers. The transport layer is built on standard protocol, so it plays nicely with existing enterprise infrastructure. We are not basically asking you to rip and replace your whole network stack. The message format uses standardized or structured JSON schemas for request response patterns. And there's typing validation happening. There's a security layer that implements OAuth 2, mutual TLS, role-based access control of the protocol level. And then we also have like messaging structure and flow. For example, every MCP request structure maybe have a unique ID for tracking, a method that specifies what operation we want, tool execution, resource access, prompt retrieval. All the parameters section contains specific parameters for that operation. And the meta section includes timestamp, resource identification, or encrypted authentication context. Then we have the tool execution pattern. For example, this allows AI agents to execute specific functions within your enterprise environment. The agent sends a tool execution request, the MCP server validates those permissions and checks role-based control, time-based control, and then returns the result with full metadata. we can also do resource access pattern, and it provides control access to enterprise data. The agent requests specific resources. For example, the server applies those access policies based on who is asking, really. We also have prompt template pattern, and this is really clever because it enables dynamic prompt generation based on context. The agent requests the prompt template, the server evaluates the current context and permissions to generate a contextually appropriate prompt. And then we also have connection management between those sessions handling. In enterprise environments, connection management is really critical. MCP implements sophisticated connection management. Connection pooling maintains persistent connections to reduce efficiency for high frequency operations when you are processing thousands of transactions. Sessions state tracking maintains conversation context across multiple interactions. The AI agent doesn't have to start from scratch every time. The protocol ensures connection hard with configurable timeout intervals. We know immediately if something goes wrong. And then there is like graceful degradation that handles network interruptions or server failures without losing critical state. So here is also how MCP works, and this is from the Hugging Face website, is the architecture program. It's like we have an MCP server, and this is the whole protocol that unifies all of the different resources and the tools that we have with some local data resources, and it can talk to actually some sort of client, and that client can be connected to any framework that builds different agents, and that is really brilliant. So now we talk a little bit about MCP versus modern API architecture. So basically we have in this case an execution model. In MCP batch processing, the execution model is scheduled, it is sequential, the jobs are self-contained. But in modern API, it is based on demand and stateless interactions. The workflow in MCP is predictable, it is recurring with fixed parameters. However, in modern API, the workflow is real-time integration with distributed services. The logging is really important here. It is centralized in mainframe environment, but in modern API, per transaction logging happens. Resource usage in MCP is incentive, but it is very reliable versus API, which is lightweight but requires an orchestration in this case. And then we have AI-powered MCP. Basically, we are building really legacy reliability with modern intelligence. There are 4 pillars to our modernization strategy. One is that the MCP takes over the job scheduling and job control model. Instead of having static scripts, we are replacing it with agentic AI and intelligence. And we maintain enterprise-grade logging and monitoring as part of the MCP because all of the messages, all of the communication between those agents have been tracked. And we also apply dynamic content generation. So because it is agentic based and it has the capability to come up with new concepts, and on the fly, we enable these dynamic content generations. So as a result, the AI agents that operate within traditional batch processing frameworks can actually collaborate with each other, generate contextual and meaningful and intelligent outputs as part of the process. Now, if I want to talk a little bit about the enterprise intelligence patterns here, what I have to say is that there are actually 4 main patterns. One is that we have different integration approaches. It enables different integration approaches. And for example, we can have request reply pattern. This is basically synchronous interaction with AI agents that sends a request and waits for a response. So that is, very well understood. Or we can have, POC patterns, asynchronous notifications when the AI agent subscribes to events from enterprise systems. It provides file system bridges. Basically, it processes legacy file formats and outputs. It also generates all of the required information in the output format for later doing auditing and monitoring jobs here. So also we have, it enables API gateways, connects modern systems while maintaining those previous batch patterns. It doesn't have any conflict with previous integrations. And finally, we have message queues. As I said, for example, pops up can be integrated into these operations. Next, I want to talk a little bit about the security considerations and compliance. For example, we may have, different security considerations. For example, GDPR compliance or SOX compliance or HIPAA compliance or enterprise security integration. AI agents can access minimum data based on the required compliance requests here. So we've got multi-layer authentication, client certified certificates for device level authentication. Then we have the JWT tokens for user level authentication or service account credentials. Then we have an authorization framework that includes resource-based permissions, read, write, execute on specific tools. We also can have data protection, which has end-to-end encryption for all protocol messages. It provides access control is part of the process, and it actually provides role-based access control for the different resources. Auditing and logging is integrated as part of the process, and of course network segmentation and access controls are also provided as part of the process. There are really different real world use cases of these systems. For example, in financial services, automating regulatory reporting with AI insights or risk analysis summaries. We can have multiple agents that do risk summaries, and these agents can talk to each other using MCP protocol. In healthcare, patient care summaries and reports, as well as research analysis and literature reviews. In manufacturing, a lot of reporting and summarization, supply chain analysis, safety incident reporting is another use case of this technology. Finally, I want to talk a little bit about some key takeaways. Here is what I want to take away from today. The MCP protocol for AI represents a fundamental shift in how we think about enterprise AI integration. We are not talking about ripping out systems that work. We are talking about intelligently enhancing them. From a technical standpoint, this protocol provides enterprise-grade security and reliability for AI interactions. The extendable architecture supports custom tools and integration patterns, built-in compliance and governance features, address regulatory requirements, performance and scalability features are all provided here. So this enables gradual AI adoption without disrupting existing systems. It provides a standardized approach to AI interaction. It creates a foundation for advanced AI capabilities like autonomous agents. The future of enterprise computing isn't about choosing between reliability and intelligence. It's about combining them systematically through protocols like MCP. And finally, there are some, action items that we can have. We have to think about the future. So it has 4 main parts: assess, start, build, and measure. We want to assess the current systems as we did for MCP. We want to start small, begin with non-critical reporting and communication tasks. We don't have to jump big, but we can build incrementally, add different layers of AI capabilities into our infrastructure, and finally, we can measure impact, take efficiency gains and quality improvement.
If you liked this video, you will love what I have to say next. The 14-week Agentic AI program at Interview Kickstart helps engineers build real, career-ready skills. You'll work on 2 live projects with FANG instructors and lead with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying upwards of $300,000. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the Agentic AI building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.